Hey there guys, how's it going? Mike coming back at you with another video on discrete mathematics. In the previous video, we continued our discussion about sets and some special yet common sets that we work with. And then we talked about some other sets that we're not going to focus on much, but they are out there, like the power set and the Cartesian set. In this video, I just want to go through a couple more sample problems, get some more practice with finding the union, intersection, difference, and complements of one or two sets, just to help us get a bit more familiar with these concepts. So here I have a universal set. In this case, the set is R. It's a set of all real numbers. Let A equal the set of all x in R such that x is greater than -7 and less than or equal to 5. And let B equal all real numbers that are greater than or equal to -1. And we're going to find the union of these two sets, the intersection of these two sets, the set difference B minus A, and then also a complement. Now, just as a couple quick notes before we actually go into finding these guys, notice that in the definition of A and B, I wrote out the x is in R such that, and then my following property. Because I identified my universal set U as R, I could have just written U, or I could have just not written that there. And I could have just said, let A be all numbers less than -7 and greater than -7 and less than or equal to +5. I could have just written that all out in words. I also could have written this using interval notation as well. That'd be another way to represent these sets. In fact, you may want to write these in interval notation on your own, just to perhaps make things easier. But first up, we're going to find the union of these two sets. So it's everything that's in set A or everything that's in set B. Combine all those things and put all those things inside of a set. A is all things between -7 and 5, and also including 5. B is everything greater than or equal to -1. So if you were to draw those things out on the real number line, and you were to see where does something fall into either one of those two sets, you would see that the union is all real numbers that are greater than -7. So that is the union of A and B. It's all real numbers, x such that x is greater than -7. Because B is everything from -1 all the way up. A is everything between -7 and +5 and including 5. Just a quick recap of what we said earlier. The intersection, what things lie in both sets A and B simultaneously. So if you drew this out on a real number line, if you had a separate marker or separate color for what's in set A and a different marker or color for what's in set B, where do those things overlap? If they do, then what you would find is that your intersection is all real numbers between and equal to -1 and +5. Give me any number between or equal to -1 and +5, and they're going to lie in both A and B at the same time. We have the set difference, B minus A. These are all the guys in B which are not in capital A. So looking at B, it's everything from -1 up. And A is everything between -7 and +5 and including 5. Well, we know that if we have something between or equal to -1 and 5, then it lies in the intersection of A and B. So that doesn't mean it's in the difference set. It's not in B minus A. But once we get beyond 5, it lies in B and it does not lie in A. So every x value greater than 5 is what will constitute our difference set B minus A. So that is our difference set. Every real number greater than 5. And now a complement. Everything that is not in A that lies in our universal set R. A contains things greater than -7 while simultaneously being less than or equal to +5. So what doesn't lie in that set? It's all numbers less than or equal to -7, or it's all numbers greater than 5. So that is exactly a complement. It's all real numbers that are less than or equal to -7, or it is greater than 5. So this may seem a little bit familiar, going back several years into maybe pre-college math, where you do these kinds of practice problems. But this is another way to look at sets. This is a more familiar way to look at the union and the intersection of sets, using a common domain that we work in mathematics, which is just the set of all real numbers. The other example I want to show, our universal set is Z, set of all whole numbers. A is going to be the set of all even integers. And I've picked out a few numbers and I've thrown those together and I've made those set B. B is -4, 4, 10, 14, and 26. And we're going to, again, find the same 4 sets. Now, before we actually go through finding these things, look at set A, look at what it's defined to be, and look at set B and the elements in set B. Notice that every element that's in B is an even whole number. So by definition, B is a subset of A. So we're going to see what these things turn out to be. We're going to see what these 4 sets turn out to be, specifically the first 3, when B is a subset of A, or just in general when one set is a subset of the other. So the union is first up, A union B, all the things that are in A or the things that are in B. Well, we said that everything that's in B is in A. So what's in either one of those sets is simply just the set of all even integers, which is set A. So A union B in this case is just A. Next up is the intersection, all the things that lie in A and B simultaneously. Well, again, everything that's in B lies in A. So the intersection of these things, when one set is a subset of the other, the intersection of the 2 sets is simply your smaller set. It is -4, 4, 10, 14, and 26, which is exactly your set B. Next up, the difference set, B minus A. All the things that are in B that are also not in A. Well, again, everything that is in B is also in A. -4, which is in B, is in A. Same thing with 4, 10, 14, and 26. So by definition, there are no elements that are in B and not in A. So therefore, by definition, the difference here, B minus A, is going to be the null set or the empty set. And then we have a complement left to find. The universal domain, the universal set, is all whole numbers. A is the set of all even whole numbers. So what are the other things that make up the set of all whole numbers that aren't even? Well, they're all the odd whole numbers, or the odd integers. So that's what a complement will be. It's going to be the set of all odd integers. So these were just a couple quick, fairly low-level sample problems just to help us get more practice with finding the union, intersection, difference, and the complement of two sets. If you have any questions or comments, be sure to drop them in the comments section below. Otherwise, until the next video, take it easy, guys.